Hello everyone. Today I am presenting the paper which I have submitted to Fracture and Integrity Journal, Optimization of Damage Repair with the Piezoelectric Actuators using the Taguchi method. Myself, Dr. Abdullah Abid, currently working as a researcher at Prince Sultan University, Kingdom of Saudi Arabia. For this paper, the co-author is Professor Miftah Harari and Jafar Syed Muhammad Ali from International Islamic University, Malaysia. In today's presentation, I have abstract, introduction, problem definition, finite element method, design of experiments, and conclusion. In the abstract, we are using the ANSYS software to simulate the results. The results we are going to finding is a stress intensity factor for active repair. We have considered the crack plate in which we are using the bonded piezoelectric actuator. And the second thing what we are using here is we are optimizing the different configuration from the plate, from the adhesive bond, and from the piezoelectric actuators. Further, whatever the parameters and the variables we have changed, for that we are using the design of experiments method in order to optimize the optimal performance of repair method. In the introduction, we have just main theme of work optimizing the crack structure bonded with the piezoelectric actuators using the FEM and the DOE method. For this damage plate, piezoelectric actuator repair, finite element method, and design of experiment, these are the combinations very much important. As you can see the problem definition, we have a crack plate at center crack, and we have a bonded piezoelectric actuator. To bond, we have using the adhesive bond. For that RL 2014 we are using it, and we are bonding, and there's a tensile load, and that tensile load we are using as a for the crack propagation, and further we are repairing using the piezoelectric actuators. So you can see in the figure, finite element method is a simple figure in which you can see the three-dimensional view of figure in which we have a mesh, high quality of mesh. We use it, and we tested also mesh independent study, and everything is clear in this photo, which you can see the plate, adhesive bond, crack, designing the crack, and repairing piezoelectric actuator. For that, what are the parameters and their property we can see in the table mentioned in this slide. So further, design of experiments, it is very simple process. We have just identified the factors, then levels, and selected the factorial designs, then assigned the interactions and design, performance the simulations, analyzes the data with the DOE, and then optimizes the results. As you can see, the last column of this table is a simulation results which we have received from the finite element method. Further, we use these results to optimize the repair performance. Before proceeding to the results, so we have check how the simulation model are working. We are validated with the existing work. For the first case, we have used the Tada's analytical method, and for the second case, we have considered the Abu Zaid experimental work. When we compared it, it is less than 10% relative error. Then we are sure confident that our model is correct, and we can proceed with the further study. In the results and discussion, as you can see, we have three types of plots here. You can say contour plots, main effect plot, and interactions plot. Contour plots mainly it is defining how the parameters are affecting to the stress intensity factor. So by color changes. But in the main effect plot, you can see what the optimum ratio of the parameters what we have going to using. As you can say, center line, with the center line, how much is parameter, how much is varying from plus and to minus. In the interactions plot, sometime what will happen, some of the points are related to each other. So we are seeing that if I'm going to change the one parameters, whether it is effective to the other parameters or not. So meanwhile, in our case, most of the cases interaction are not happening, but in some cases you can see in the last in the third column, second row, and second column and third row has some interactions. And in other cases it has a linear interactions. As you can see in these tables, we have a coefficient table and the ANOVA table. Coefficient table and the optimization table. In the coefficient table, we can define how much the parameters are affected to the stress intensity factor value. So some of the parameters are affect more and some of the parameters are affect less. So in this coefficient table, we can find it. And the response optimization table is one. This you can see the main contribution of this work, in which you can recognize the how these parameters are affecting to each other, and what are those values to get the optimum results of stress intensity factor. So when some parameters high, when some parameters low, so it is depend upon what is the optimal parameters and its level to optimize the stress intensity factor. Further, this value we have validated with the simulation results, and we got the same accuracy in both results. So as a conclusion, detailed exploring into utilizing piezoelectric for active repair in a damaged structures, employing the design of experiment methodology. Methodology established for the effectiveness of different design combinations to reduce the stress intensity factor. Significantly lies the advancing material optimization of the structural integrity, offering the potential for improve the piezoelectric actuator design. Thank you for the listening.